Atomic number and mass number. Electron, proton, and neutron are called the fundamental particle of all type of matter. In other words, the atom of all the element present in this world contains same electron, proton, and neutron. However, an atom of one element differ from an atom of other element because it contains different number of the fundamental particle. The number of proton present in the atom of an element is always fixed, and it is called the atomic number of that element. Since an atom as a whole is electrically neutral, the number of electrons present in an atom will be the same as the number of protons. Atomic number of an element is represented by Z. Atomic number of an element is unique to that element, and the element is identified by this number. In a periodic table of elements, the elements are arranged according to ascending order of their atomic number. The total number of proton and neutron present in an atom almost count for the total mass of that atom, and hence it is called nucleon number or mass number. It is represented by A. The mass of electron being very small is not included in the mass number. Just like atomic number, the atom of an element may also be identified from its mass number. For example, the number of protons present in an oxygen atom is 8, so its atomic number is 8, while the total number of protons and neutrons present in it is 16, so its mass number is 16. Information about the atomic number and the mass number is often included with the symbol of any element. The atomic number is written as a left subscript while the mass number as a left subscript, so oxygen atom will be symbolized as oxygen 816. Similarly, carbon atom symbolized as carbon 612, which have 6 proton and 6 neutron. The number of neutron and present in an atom can be calculated from its atomic number, and mass number are known. N is equal to A minus Z. Thus, the number of neutron in sulfur atom symbolized as S1632 can be calculated as 32 minus 16 is equal to 16. Isotopes and their masses. All the atoms of an element must necessarily have the same atomic number, but their mass number may vary depending upon the number of neutrons present in the nucleus. Atoms of the same element having different number of neutrons in their nuclei are called isotope. For example, element carbon have 3 isotopes and its atom have 6, 7 and 8 neutrons in their nuclei. These isotopes are represented as carbon 12, carbon 13 and carbon 14. Similarly, hydrogen exists as 3 isotopes: hydrogen, deuterium, protium, deuterium and tritium, represented by H1, H2 and H3. Hydrogen 1 is the only atom which does not have any neutron. Since the chemical properties of the element are determined by the number of electrons, all 3 isotopes will show almost the same chemical behavior, although their physical properties may be different. Hydrogen 1, 2 have twice the mass of hydrogen 1, while the mass of hydrogen 3 is thrice as the mass of hydrogen 1. Similarly, the masses of 3 different isotopes of carbon are also different. Radioactive isotopes. The isotopes of the same element do not have the same physical properties. Several isotopes of the same elements exist whose nuclei are unstable. They emit excess energy in the form of radiation. This process of emission of radiation is called radioactivity, and the isotope which emit energy is called radioactive isotope. Tritium is a radioactive isotope, and the other 2 isotopes of hydrogen are stable and do not emit any radiation. When a radioactive element emits radiation, it is transformed into another chemical element. This process is called radioactive decay. This new element may be stable or may be radioactive, so that it also emits radiation. Application of radioactive isotope. Radioactive isotopes are useful in medical. Doctors use them to diagnose the disease by injecting the patient with a small amount of radioactive fluid. Technetium is used for diagnosing across human organs like brain, lungs. Doctors use a specific camera to watch how the radioactive fluid moves. Radiocarbon dating is a method for finding out the age of an historical object containing organic material with the help of radioactive isotope of carbon-14. The method involves measuring the properties of carbon-14 in a sample from a dead plant or animal like a piece of wood are a bone which provide information that can be used to calculate when an animal or plant died. The older the sample is, the lesser carbon 14 is to be detected. Radioactive isotopes are used to test the strength of metals and concrete mixtures. They are used to generate cheap nuclear power and to find oil fluids. In medicines, they are used to diagnose and treat many medical conditions and diseases, including cancer and thyroid disorders. Ionization of atom by a radioactive sources. Radiation emitted from a radioactive source causes atom to ionize. For example, radiation emitted by a radioactive element radium 226 can remove electron or electrons from the atom. However, this ionizing radiation should have enough energy to remove the tightly bound electron from the orbit of an atom. Electron can be lost because an ionizing radiation collides with the atom and forces the electron away from the atom. It an atom of sodium is hit by an radiation, it may lose an electron. This process converts the atom into a positively charged ionic cation.